Hi, everyone. Thank you for joining the webinar. We will be having a deep dive into real-time analytics for games ran on AWS. My name is Daniel Lee. I'm a solutions architect here at AWS, joined by my colleague, Gina Gizzi. We both support the games industry and support the games team. So the games team at AWS is focused on helping you create awesome games. Our team supports AWS Game Tech, which provides robust and scalable solutions for every stage of your game's lifecycle, whether it comes to the AWS services that we offer, our Twitch integrations, or even our managed game services like Amazon GameLift. So what we'll be talking about today is all about real-time analytics. We'll be going over real-time analytics and how it works on AWS, the product ecosystem for analytics, going over how an architecture for an analytics pipeline will look like on AWS, how you can integrate your game through game engines, and a demo of data going through an AWS Analytics pipeline. So I'm going to pass it over to Gina, who's going to be speaking to real-time analytics on AWS.
So first, let's talk a little bit about what real-time analytics actually is, what the business value is for actually having an analytics pipeline in a video game, and we'll also take a look at some customers who are doing this on AWS today. So here is Supercell's policy. Supercell is a company well known for game titles like Clash of Clans and Clash Royale. They say that analytics can't make a hit game, but can definitely improve it. To them, analytics is very important to improve their games and to actually keep their players around. So Supercell's been focusing on improving their analytics pipeline for a very long time. This is especially important depending on the type of game that you have. So for Supercell, they have free-to-play games where analyzing player spend is actually very important to help them better monetize their game. So here are the high-level demands of analytics in games. We often see that having an analytics pipeline and getting insights from data can help you do things like create more engaging games. And you can do this by improving your game design and optimizing your gameplay experience. So for example, if you, let's say, you instrument your game to emit game events, you can analyze that data to reveal how your game is being played by your players and use that data to enhance the game design for better overall engagement. You can also use analytics to help with fraud detection and to prevent cheating. So fraudulent behavior can be really disruptive to the game experience, and it can oftentimes ruin the enjoyment for your other players. So it's important to have a plan so that you can understand when fraud happens and that you can react quickly to avoid it having a negative impact on your games and a negative impact on the player experience. You can also use analytics to do things like monitor performance and error reporting. So this can help you with things like improving your game infrastructure. So by understanding important metrics like CPU and memory utilization, you can know when your peak usage times are and use these metrics to scale your infrastructure accordingly. You can also use analytics to better monetize your game. Are users that play the most also spending the most on in-game purchases? So like Supercell, this is important depending on the type of model of your game. Is it a free-to-play game with microtransactions, or is it a one-time purchase type of game? Finally, analytics can also help with things like instrumenting live ops, or even later on down the road, including machine learning, AI ML into your game. So now that we know why we want to use analytics, what does an analytics pipeline even look like? Here are the four main components that actually make up an analytics pipeline. So there's the ingest collect phase. So how are you going to ingest data in a timely fashion from all of your players or all of your data producers, whether that's your game clients, could be PC, mobile, console devices, it could be your backend services or even multiplayer services. Or multiplayer servers. How do you actually ingest data from all of those different data producers? The next is store. Where and how are you going to store all of your data? Is there going to be PII information? How are you going to organize and partition this data? How are you going to secure it for future use? Next, how are you going to process and analyze your data? What different tools are you going to do? Are you going to use? Are you going to do ETL, extract, transform, and load to process your data? And finally, how do we actually visualize your data to get useful insights for your game, both for batch and real-time data? The second thing that's important to understand when it comes to analytics is that the data you collect has a shelf life. The older data becomes, the less useful it is in helping you with timely reactions. So you really need to consider the questions you have and the type of answers that you want to get to know when is the best time to look at your data. So to address this, there are typically two different types of data analytics pipelines. We have batch analytics pipelines and also real-time pipelines that allow you to get insights at different speeds. So real-time analytics, or also known as near real-time analytics, is analyzing data as soon as it comes in, either in real time or in seconds or even in minutes, while batch is doing analytics on more historical data. So this could be data that's collected over a period of hours, days, or even months or years, right? So for this webinar, we're going to specifically focus on how to set up a real-time analytics pipeline on AWS. So here are just some customers that are doing this on AWS today. So what we're going to show you has been tried and tested, and the services that we're going to talk about have been used by many game companies today for analytics. So for example, we have Epic Games here who have built a data lake on AWS to analyze billions of events that are generated from their game Fortnite. There's also Zynga that analyzes streaming data from Words with Friends using Kinesis Data Analytics, which is actually a service that we'll talk about later on in this presentation. We also have companies like Rovio who analyze billions of events per day with services like S3, Redshift, EMR, and other tools. One thing that I want to call out here is that depending on the size and the maturity of your game studio, you might not have a dedicated analytics team to help manage infrastructure and to get insights for you, right? You might not have a data expert or a data scientist on hand. However, analytics is still very important. So today, the services that we're going to show you are all serverless, which means that they're all fully managed and don't require infrastructure management, so that you don't need to rely on a dedicated team to manage that infrastructure for your analytics pipeline. So let's talk about some of the serverless AWS services that you can use to build out a serverless real-time analytics pipeline. So first, I just want to show you the AWS Analytics Ecosystem. We have a lot of services in our analytics ecosystem. We have services that are serverless and fully managed. We have services where you can manage the underlying infrastructure or clusters. And we even have services that can be used for both batch analytics and real-time analytics. So you can see that these services are categorized according to the different stages of an analytics pipeline. So we've got services that can help with data movement, for example, or data ingestion, right? We have services that can help with storage or data lake infrastructure and management. We have services that help with analytics, including processing data, doing ETL, extract, transform, load, as well as running queries. And we've also got services at the top there that help you do things like visualize your data and even get deeper insights using AI ML. So you can see some of our AI ML services are also listed there as well. So what's great is that a lot of these services are plug and play. They're all integrated with each other. They all work really well with other services within this AWS ecosystem, which means that you can choose the tools that are right for you to create your data analytics platform based off your specific use case. So there's not one right way to do it. We definitely don't have enough time to cover all of these services today, so instead we're going to focus on just a subset of these services, the ones that are serverless and fully managed and also can be used for real-time insights. So let's take a look at what some of these services are. So the first service that I want to cover is Amazon Kinesis. So this helps us ingest our streaming data in real time. So there's actually 4 different flavors or versions of Amazon Kinesis. There's Kinesis Data Streams, Kinesis Data Firehose, Kinesis Data Analytics, and there's actually also a 4th one called Kinesis Video Streams, which isn't commonly used for analytics in games, so we're only going to focus on the first 3 here today. So the first one is Kinesis Data Streams. This is real-time data streaming with your own custom producer and consumer applications. Next, we have Kinesis Data Firehose, which is real-time data streaming to one of 4 built-in destinations. This could be S3, Splunk, Redshift, or Elasticsearch. And then we have Kinesis Data Analytics. So this is real-time analytics on streaming data, which basically can allow you to run SQL queries on data as it comes in. So if we think of an example, you can do something such as a continuous filter streaming query so that we can, let's say, look at a subset of player data from a certain geographical region. What's great about all of these services is that Kinesis is serverless, it's fully managed, there's no infrastructure to manage, it takes seconds to provision so you can get started really quickly. So basically, at the end of the day, Kinesis helps us ingest our data. It helps us with the first stage or the first component of a data analytics pipeline. The next service is AWS Lambda, which can help with data orchestration and basic ETL, organic extract, transform, and load. So Lambda is basically a serverless compute capacity service in the cloud. It lets you execute code without managing any infrastructure. You basically just upload your code and Lambda takes care of everything required to run and scale your code with high availability. So it's really great. Lambda supports various different runtimes, including Python, Node, Ruby, Java, Go, and .NET. And it can also be used to execute code for just about any use case. But specifically when we're talking about data analytics, Lambda can be used for things like data orchestration, as well as it can even be used to do some basic data processing or ETL. So for example, with Lambda, you can do things like consume data off of a stream from Amazon Kinesis, or transform data to another format like from JSON to Parquet, or even execute AWS SDK code, or even move data between distributed components of your pipeline. So the possibilities here are endless. The last service that I want to talk about is Amazon CloudWatch, which collects monitoring and operational data in the form of logs, metrics, and events. So this can help us provide a unified view of all of our different AWS resources and services that actually run on the cloud and even on on-prem servers. So you can use CloudWatch to detect things like anomalies in your environments. You can set alarms, visualize logs, and even metrics side by side in a dashboard and take automated actions based off of the alarms that you actually set. So it's really great with helping to troubleshoot issues and discover insights to keep your applications running smoothly. So for our purpose, we can actually use CloudWatch to create real-time custom dashboards to monitor our incoming data, again, in real time. So this could be used for both operational data as well as for game event data or any custom game metrics that we want to monitor in real time. So now that we know what services we can use, let's take a look at how we can combine all of these services to create the architecture for a data analytics pipeline. So first, we start out with our data producers. This could be anything that we want to collect data from. So it could be our game clients, such as PC or mobile or consoles. It could be our backend services, like maybe we have servers or that are used for multiplayer. Anything that we want to collect data from. And we can ingest that into our data analytics pipeline directly to Kinesis data streams, which again allows us to ingest real-time streaming data from our own custom producers and consumer applications. So we ingest that data with Kinesis data streams. And from Kinesis data streams, we can send that stream of data to Kinesis data analytics. And this allows us to run SQL queries or basic ETL on our data in real time. And then we have a Lambda function, which is serverless compute capacity, that's actually consuming our filtered data or our processed data from Kinesis data analytics. And in that Lambda function, we're actually using the AWS SDKs or the software development kit to create custom CloudWatch metrics so that we can generate a real-time dashboard using Amazon CloudWatch so that we can view our metrics, again, whether those are operational metrics or game events that we actually want to view. We can view that data in a custom CloudWatch dashboard. So this is our real-time data analytics pipeline, but I do just also want to include some information about how we can store that data for batch and historical purposes later on, because currently in the pipeline that we just talked about, we're not actually storing that data. So what we can also do is in parallel, we can send data from Kinesis data streams to both Kinesis data analytics and Kinesis data firehose. And again, Kinesis data firehose is a service that allows us to send real-time streaming data to one of 4 built-in destinations. One of those is Amazon S3. So Amazon S3 is our simple storage service that allows us to store objects in the cloud. It's highly available and durable and makes for the perfect data lake. So we're just storing all of the data that we're collecting. This could be raw data, processed data, it could be pre-processed data, structured, unstructured, semi-structured. We're storing all of our different types of data that we're collecting in one centralized location so that we can make it easy to do batch analytics later on. So this is what our real-time analytics architecture actually looks like on AWS. So first things first, how do we even ingest data from our data producers into our data analytics pipeline? Let's take a look at how we can integrate AWS services with a game engine such as Unity or Unreal. In this specific webinar, we'll be using Unity as our game engine. So there are 2 different ways that you can integrate AWS services with a game client such as Unity to send data to your analytics pipeline. The first is direct integration using the AWS SDK, which is our software development kit. The second is using an API proxy with our service Amazon API Gateway. So for option 1, what this looks like is sending data from data producers directly to Kinesis using the SDK as shown here in this diagram. So you would use this method if you want to publish events from your games and your services directly to Amazon Kinesis without actually using an API gateway. So this is good because it actually removes the added cost that's associated with using API Gateway. And it also can be useful if you're a game developer who's new to AWS services but familiar with C# and .NET libraries. So what option 2 looks like, on the other hand, is a proxy API sitting in between your data producers and your backend services. So in this case, your data producers send data to API Gateway with an HTTP post, which triggers a Lambda function that actually executes the AWS SDK code to send data to Kinesis. So instead of writing AWS SDK code in your game client, you're actually executing that SDK code in a backend Lambda function. So what's good about this option is it provides an extra layer of security to actually separate your backend resources away from game clients if you're trying to abstract as much as possible away from the player. Both of these methods can be used for cross-platform game releases, including mobile games, PC games, and console games too. So you can choose whichever integration method you're more comfortable with. However, for this webinar, we're going to highlight the very first option, which is direct integration with the AWS SDK. And we'll actually show you an example code of what this looks like and how it looks in Unity. So let's run through some of the AWS SDK code that we use in Unity to send data to our data analytics pipeline. So because we're actually using Unity, we're choosing to use the AWS.NET SDK in this case. So first, what we do is we need to create a Kinesis stream name. So this is just a string variable that we're going to call KDS stream. And then we need to actually initialize a Kinesis client, which we do in the second line of code here by creating a client variable and passing through a set of credentials which allow us to have the correct permission to actually access and use our Kinesis stream, as well as the AWS region that our stream is actually in. After we do that, we can call a put record, which we're actually using the asynchronous option here, where we pass in data to our Kinesis data stream, specifying what data we actually want to send and the name of our stream. And that's pretty much it. So let's see this in action in Unity. So here we have a Unity game. This is actually a Unity tutorial that's called John Lemon's Haunted Jaunt. We took this tutorial and we actually integrated our analytics pipeline into it. So we've instrumented this game to emit game events every time the player wins or every time the player dies. So what this game is, it's John Lemon and he's in a haunted mansion and he's trying to escape the haunted mansion, which is a maze, while avoiding enemies, which are ghosts and gargoyles. So every time that John Lemon dies by the hands of an enemy, we emit a game event, which is our player death game event. And every time the player wins, we emit a player win game event. So we're sending data every time there's a player event to our data analytics pipeline. And you can see here we have a ton of different scripts. Some of these are included with the tutorial to make the game to work, but we have one here that is our Kinesis data firehose script that we're using to send data to our Kinesis data firehose. So what this actually looks like in action is let's play our game a little bit. So we have John Lemon here who just walks around trying to escape the haunted mansion. And what happens when he comes into contact with an enemy is he gets caught. And we are sending game events every single time that the player gets caught. And we can see that we've actually sent a record in the console and that record has been received. And what this looks like in Here's my Kinesis Firehose stream. It's called our real-time webinar stream that we created. And we can see that we are getting some incoming records. Now, it's a very small amount of data, so that's why the line's all the way down here. But we can see that we do have records that are incoming from our game client that are being sent using the AWS SDK. And this data is actually being sent directly to an Amazon S3 bucket so that we can save that data for historical purposes.
So now that we've seen some example queries for a game engine, let's take a look at how the architecture would look like on the AWS console through a demo. So what we used for this demo was a game analytics pipeline solution, which is a prepackaged vetted solution that is viewable and deployable through a CloudFormation template. And basically what it would do is allow you to launch a scalable serverless data pipeline that has all the services that we've been speaking to with a real-time analytics pipeline. So what I'm going to show you real quick is the solutions page that you can also access through this URL. We'll also be providing the URL in a bit. And basically, it shows the architecture, some deployment guides and developer guides that will allow you to not only create custom components through guides, for example, your own SQL queries for real-time analysis, your own customized widgets for a CloudWatch dashboard. You also see some non-real-time components that you can potentially deploy if you'd like, but at the same time, you can tailor and customize the solution to only work with exactly what you need. And along with that, you have some source code with all of the code available in a GitHub repository. I'll be showing some of the Lambda functions code that's available here. Along with, you can deploy it directly either to the console or view the CloudFormation template as well. So let's walk through the real-time components to this solution. So for example, Kinesis Data Streams, Kinesis Data Analytics, AWS Lambda, and then the live dashboard in Amazon CloudWatch. So the data that's coming in is actually going through a mock game client that I have sending data to Kinesis Data Streams. This client is actually, the code for it is actually available in the source code as well, but it's running a Python function with the Kinesis SDK to send data through this Kinesis Data Streams, which I'm showing here. This is the Kinesis data stream that's deployed by the solution. What you can see in the monitoring tab is that there's a sudden uptick of records when I initiated this script, and a lot of different other metrics such as the health of the actual stream along with the data coming in, making sure that it's not being throttled. You can also change things like the encryption settings or even the capacity of the data that's being sent in. So if you need a larger pipe for a larger amount of data coming in, you can change it here as well. So the data that's coming in to Kinesis Data Streams is being sent directly to Kinesis Data Analytics, which is basically doing SQL queries, live SQL queries on certain windows, and it is going to pass that to a Lambda function, which is actually processing and converting the data coming out of Kinesis Data Analytics into a format that's compatible with CloudWatch through publishing it into CloudWatch metrics. So let's show all of that that's coming in through Kinesis Data Analytics. So let's go back here. So the data coming in is going to be in all sorts of formats. So for example, it's going to be coming in through JSON. but what you can do is only query a certain subset of the data and make it match a certain schema that's specified by you. For example, we have raw data that's coming in the form of JSON, and it has random things like a user was knocked out, item was viewed by a certain player, things of that nature. But what we can do is format it into rows and columns. And this data that's in rows and columns will be sent over to the Kinesis application. The application will be querying this data as if it was SQL. It can also be compatible with Apache Flink and send the resulting queries, the query data, over to CloudWatch. You can edit the schema actually, so you can only accept the different columns of these certain formats. You can even accept nested JSON, various types of data, and a specified name. So if you have new data coming in with a new column, so for example, currency value or some sort of other insight that you can make with currency, you'll be able to create and edit the schema with a new column up here, add it, save it, and then the data will then be able to be queried by the application. So let's see how the queries actually look like. So as the page loads, we'll be able to see, for example, let's see. So inside of the application, you can actually view the SQL results. And these are the actual SQL queries that are being called. So for example, there's one for finding the total amount of events within a certain period. This period specified is a window of 1 minute. Total amount of logins, number of knockouts by the spells, number of purchases, and the source data that's coming in, you've already seen it, but after we do the queries, we'll be able to see in each window of time, since we specified a minute, every minute you'll be able to see the data coming in these batches. And in these batches, you'll see some repetitive metrics, but that's because they're being grouped by different parameters. So for example, you might have multiple applications, as you can see up here. You might have multiple currency types, multiple versions of each application. So we have a metric that just came in. So it came at this timestamp, which you can convert to your own corresponding timestamp. Let's go ahead and refresh that. And what we can actually do is, as this populates, we can view how the Lambda function code looks, and then we'll be able to see how it looks like again as it's populated. So here's an example here of the actual Lambda code that you'll be able to see in the same GitHub repository in the solutions page. And what this does is convert the Kinesis data analytics data into CloudWatch metrics. There are two files that work together called by an index JavaScript file. And just showing how the code generally looks and where you can access it, you can see that we also annotate the code. What it'll do is process the output, publish it to CloudWatch, as I mentioned, but it does it through payloads, JSON metrics. It's converting each into a CloudWatch metric and parsing it as such. Let's check the analytics application real quick. Okay, this will definitely keep updating, but as I can show you, we have a certain app version, application ID, which has a certain UUID. It's a count of 78 total logins that were done in a certain minute. So that's really good to know. And as As I mentioned, in the next minute or so, it's going to populate with new metrics. Let's take a look at the CloudWatch dashboard. So CloudWatch is a monitoring service we have with a lot of different features, such as ability to aggregate logs, publish certain specific metrics that, for example, Kinesis Data Analytics is doing. You can have certain events that fire off notifications. And then in our case, we also have a dashboard. So this dashboard, this is actually provided by default by the solution. It shows operational health, so you can use this to view the actual health of your infrastructure. But at the same time, you can also add either another dashboard just for game metrics. In our case, we'll just add it all into one. We can publish a certain metric, and what you'll see is the capability to add either namespaces that are provided by various services by default, or custom ones that we've actually made, for example, the ones made by the Lambda function. We can actually select those, and they're sorted by various schemas. For example, we have one for spell IDs. I believe this is actually because of total knockouts by spell, which we can actually view now that it's probably updated by now in the application. Right, so as you can see, new data has come in since earlier, and not only do you see total amount of events coming in, but total logins, purchases, knockouts by spell. And in our case, I'd like to actually see a metric of that. So we have 17 knockouts of spells, but obviously, as you can see, multiple ones. That's mostly because they're grouped by various things like the application ID and version. In this case, it's actually the same version and same application ID, so it's grouped by something else. For example, the spell. So we have fire spells, earth spells, air spells, water spells, all sending different amounts. So what kind of insights can we gain from that? Well, we can view, let's say, for the latest application version, 1.2, we have fire spells that we can select. As you can see, it's been changing over time. We also have air spells, and you can compare them against each other. So let's say some certain things happen. For example, an event happens, an in-game event, where you can gain a new cosmetic that shoots fire spells, or a new, let's say a new patch occurred and fire spells were buffed. And what you can observe is if there are more fire spells being used, it might either be popular, or in a balanced scenario, it might be overpowered, in which case you can keep an eye on and actually track exactly how that would actually impact your game live. So if you see that the patch just went live and you need to gain that insight, you'll be able to react accordingly. There are a lot of other scenarios. We've obviously gone through a lot of them already, but this is exactly what you'll be able to do to see that insight live. Lastly, I just want to highlight real quick the notifications. You can have notifications come in from various, either, again, operational metrics, for example, changes happening to your infrastructure, or in-game events happening. Maybe you can programmatically add your player base, their emails and such, to a certain SNS topic. And once let's say a charity threshold was made, everyone who participated in the charity, after all the metrics for that have been aggregated, if a certain metric such as that total amount has been reached, you can notify all of your players and maybe even give them a in-game item or do any sort of automated event as a result. So that wraps up the demo, and we'll be speaking to some key takeaways. So now that we've seen a demo, what are some key takeaways? You can use analytics to make a fast, well-informed decision for creating more engaging games through analytics insights, showing what features or attributes of your games are popular with players. You can also monetize games through performance metrics of various in-game items or analytics on sales. There's also fraud detection through finding normal player or human activity and using machine learning with analytics to detect anomalous activity such as cheat engines, boosting, win trading, account selling, and other malicious acts. There's also the capability to monitor infrastructure performance and system activity to ensure scaling. And also live operations, such as game or service releases, or even releases of in-game events to make sure that these events run successfully. We learned what AWS services can be used for real-time analytics. We showed a great reference architecture with the game analytics pipeline solution, and the solution was made with modularity in mind. There are features such as allowing open-ended schemas for ingestion. We showed multiple methods of ingestion with SDK and HTTP proxy integration with API gateway, and the ability to change and add your own integrations so that it can fit your needs. We encourage you to reach out to us with your use case so we can mold a pipeline to work with and only with exactly what you need. We showed some examples on integrating AWS services with Unity, but with our SDK, we can integrate with many other engines supporting a wide array of other languages. And lastly, we demonstrated a pipeline in action in which you can take with you as you build out your analytics pipelines. So what's the path forward? Contact your account management team to set up a tech review with one of our game tech solutions architects, such as myself or Gina, to learn AWS best practices and how we can help you plan, develop, deploy, and operate your game. Game Tech also has a games dedicated learning path that organizes all game tech courses into one place. Whether you're a solutions architect, game developer, data engineer, or data analyst, this learning path provides structured guidance on where to begin your training and next steps to gain expertise. We also have workshops such as a hands-on training lab that prepares you to integrate the game analytics pipeline solution by getting you familiar with the services necessary to build, test, and deploy a serverless analytics pipeline. When you're ready, you can launch a proof of concept based on the game analytics pipeline solution, and you can ask your AWS account team about potential proof of concept credits to help reduce the cost of experimentation. And lastly, the game analytics pipeline solution can be found here, the link below. The assets include a reference architecture, implementation guide, and links to the GitHub source artifacts. And the solutions include a CloudFormation template to get your pipeline up and running quickly, or you can even contact your AWS account team to learn which AWS Partner Network partner is best suited to assist with the integration. So with that, thank you so much for your time, and I hope we were able to get things rolling with analytics pipelines, opportunities that you have within your organizations. If you're interested in integrating this pipeline yourself, please reach out to us.